So I decided yesterday to change this presentation this hour that we will be together, and I changed this into more hands-on, although it has some theoretical initial part. I don't know if you had the opportunity to see one of the presentations that Pedro Gonçalves from Terra do did on the scope of the Iliad hackathon, because some part of my presentation is also used on his presentation. So you may see some similar contents, although I will jump into a hands-on afterwards. So unfortunately, as I said, I'm online. I would rather be there with you. And this part of application packaging, and although the presentation is about application packaging, it might be interesting to understand why do we need the application packages and what are the background and the requirements that lead into the need to package applications or models, and let's start by this. So what we want is to enable a way to provide interoperable and configurable data processing services and tools. And by this, we mean to have an architecture, a set of standards, best practices, a set of technologies that will allow us to go forward with this ambition. Application packaging is one of the best practices that we are using in this scope. There are a set of use cases that lead to this architecture that we have defined, and as a starting point, I would say that I'm not a modeler. I don't care much about the modeling part, so I start after the modeler has a model set of algorithms, a set of tools that he defines for his pipeline. So this is a precondition of the work that we want to achieve. Then another use case is to have a software developer to create an application package. So this is the initial part of the work. Once we have the model, we start looking at the model and we try to identify which parts of that pipeline could be reused in other pipelines, and we extract them and build tools. What in a minute I will call it application package tools. And these tools orchestrated in a certain way and packaged in a certain way will allow us to build pipelines, so the application packages. Each of these tools might be put on a specific Docker container, and then we can describe this application package with enough the metadata, with the description of the inputs, the outputs, the processing steps, and so on. And these will go into a Docker container or a Docker image repository. So it will be available for anyone with access to the repository to use and reuse in consequence pipelines. Then what we will also will do, or will provide a small example afterwards. Someone else, an analyst, can find this. Sorry, I just forgot one thing here. After deploying the container image into the repository, I can register it, this tool or my pipeline, in a application package registry. Application package registry is a piece of software that serves as a catalog of models and applications and tools. And we have one example to show to afterwards. So another use case would be an analyst that is searching for a tool to use in his own pipeline. He finds this tool or the complete pipeline, and then he can deploy it to run in a computing infrastructure. Either it is HPC or cloud infrastructure, or even my own machine, as we will see afterwards. So this discovery and access to the application package is done through standard API. In the case we will use afterwards, the OGC API processes, both part 1 and part 2, for the execution and for the deployment. The part of the registry is also done with a standard API, OGC resources. This part of the deployment as a service, I started talking in the previous slide. So once we find a pipeline that we want to use, or once we describe my own pipeline, I can then deploy it through the OGC API processes software. Sorry, and ask and sorry. And and ask for it to be executed. So another use case is the ability to execute, to deploy, execute, and then undeploy the process. This is true for a cloud infrastructure, of course, but also for HPC. And then we can retrieve the results from data store or data space as defined in Iliad project. For the architecture, we took into consideration a set of technical requirements. That is the ability to reproduce the pipeline. So once the pipeline is defined, it's also easy to be reproduced and test and obtain, hopefully, the same results. So validation of the results achieved. It is also the fact that we want to make it portable. So with the application packages and with the architecture and APIs that we use, we ensure that the models can be run anywhere in any computing infrastructure with a small set of requirements. And you'll see that the requirements to run a model is only to have a Docker engine and a tool that understands the CWL language. All other requirements are inside the application package. Ensure interoperability by ensuring that these models can be run anywhere and the results can be easily achieved in an interoperable fashion. Modularity, ensuring that our pipelines can be a set of tools that can be then reused in other pipelines. In the part of the documentation, ensure that we have enough documentation on the application packaging, allowing for versioning and tracking of this versioning on the models, and also having security in mind. So the overall architecture, the models that compose this architecture for processing application packagings are these. So we have the application developer on top. It will use Docker APIs to register and to maintain the Docker images for the application packages. It will have access to a registry to ensure that it is also findable and accessible by other consumers. The deployment and execution service client are any client that is compliant with these APIs. The computing infrastructure might be any HPC, cloud computing, or services that are available and comply to the OGC API processes. And the execution, of course, will be on those machines. That blue cloud on below, it means that I can use any cloud machine on the cloud to run my processes, and I will also do an example afterwards. All these are meant also to be available on the marketplace, so all the models that will be available through the registry, allowing also for machine readable and machine interpretable descriptions of the models, will also be available on, or at least I expect to be available on the marketplace. So have a user interface with the users. So what are these application packages or Iliad applications and models? Are a set of command line tools with numeric test wall and data parameters organized as computational workflows. In fact, the application package refers to a comprehensive collection of software, resources, specification that are bundled together in a Docker image designed to distribute and be distributed and executed with specific data processing workflows. It has two parts, the part of the container and the part of description, and this is the fundamental one, this is mandatory, as a CWL file. So on the application container, on the Docker container, it has a set of tools. For example, your Python script, your shell script, C++, R, whatever you want to run as a tool, and that is containerized and deployed on a repository. And the CWL part is a text document, a YAML document, formatted document that describes the computational processing, and that can be interpreted by a set of technologies that are available, and can then deploy and orchestrate the execution of our processing workflow. I think I already said this one, so I will jump this. There are a set of recommendations that we do for the part of the application packaging, although some are, if you understand what, or if you already know how to containerize applications, some of these will be easily understandable by you. So as far as possible, use package managers to ease your process. To achieve modularity, we recommend to have each tool in a separate container for easeability of use. Try to ensure that you have easy and understandable versioning on the application packages, in part on the container images. On the Docker image file, avoid using the entry point directive. The entry point directive will force the execution of a command every time the container starts. If required, use the CMD, the command one that you can override afterwards. Try to reduce the container image size. It's easy to build an image with several hundreds of megabytes. So try to avoid using, for example, Ubuntu images as a starting point to create the Docker images to avoid the size. As far as possible, keep data that you are using on the processing outside of the container, or else you will have some issues with updating that data. Always check software and data licenses on what you are sharing. Make it discoverable. Always document the best possible way using not only the CWL documentation, but also, as we will see in 2 or 3 slides, also the metadata that we describe as required and optional to head to the CWL description. Provide reproducible and documented builds. Always try to have a repository for identifying or for sharing how you build your tool so that others can validate your results also. And of course, provide useful help messages for the users. So the CWL is a specification for describing the analysis workflows and tools. It is portable, so it fits with our requirements and is designed to meet needs of data-intensive science such as bioinformatics, medical imaging. It's already used, and it's something that we can build on too. The document has some parts. I will just highlight some of them here, but in the hands-on, I will go into more detail in some of these parts. So to describe a process, we do need to have a service definition, defining a workflow class, having the label, the documentation, and the ID of the process that we want. We need this ID to make sure we can execute it afterwards. We do have some requirements, not focused at the moment, but we do need to describe the inputs that we will use in the tool, or in this case, in the pipeline. Workflow is for a pipeline, and which outputs and the type of these outputs will be produced in the end after processing the workflow. As we are describing a workflow will be a series of steps. These steps are defined as an acyclic graph, and then on the workflow manager, on the software that reads this CWL file, if possible, it will parallelize some of these steps to achieve a faster result. The steps are defined in an option steps. This will define the sequence of the operations. They will run some other parts. I will go into this. And this is defined by saying, for example, run this command line tool, and it has as input an NBR parameter whose source is the output from that step NBR. So for each of the steps, I'm defining which are the inputs, where they come from, what's the previous step, and what will be the output. These outputs will be then used as inputs in the following steps. In the end, my workflow will generate an output, and this output will come out of one of these steps or from several of these steps. Each of these steps, as I said, it's a command line tool. A command line tool is another class that we will describe in our CWL file, and is at the command line tool level that we define. Let me see if I have it here. Yes, it's here. That we define where the Docker image is to be fetched from. So when we define a tool, we have to define also a container image, and then on the description we say, okay, my command line tool whose ID is something has as requirement the fetching of that Docker image to generate a container that then will be run with this step of my overall pipeline. At the CWL file, we will then use a set of metadata. This comes from schema.org. It's additional to the elements of the CWL that we are already defined, and mandatory. We have the name, description, keyword, software version, source organization, author, code repository, and date created. And as optional, other contributors, the maintainer, license, citation, the string, programming language, temporal coverage, and spatial coverage of the processing tools and pipelines. Then you can, I will start putting some links on Discord, on the general, so that you will have access to this presentation afterwards. But where is it? That you can also be looking into it. Discord, it's here. It's on the general channel. You can then also register your application packages and tools on the registry, and there are some querybles to search and identification of the querybles. This is meant to be used in a computer-to-computer interface, but we did some just example boxes here to register application packages and to search for the application packages. Those that are available at the moment, we keep cleaning this because we are under development also, are these ones. So one of those will be used, the others will be shown during the presentation now. So there are a set of skills that it's expected to know and to have to perform an application package. There are some open standards and technologies whose links I share here with you. And let's jump into then the tutorial to make some hands-on. Where is it? Okay, let's start with this one. Hopefully it will go well, because this was made yesterday, and this was one idea to have a more hands-on approach on this class. So I will move this here, and I will create a key development environment so that I can use. I'm not sure how can I do like this. Okay. So for this first example, my idea was to have hello world, starting by an hello world always, having an hello world Python code that we want to containerize, and we want to provide as an application tool, as an application package tool, and as a processing pipeline with only one step, so that we can see how to implement our application package. So I will name this hello world.py. You can follow the names there. I'll do my own version. And what we have here is Python application that the only thing that it does is to accept an argument on the call to the Python script, and provide an hello, and print the version of the Python. Let me just open here, and this is. Oh, okay. So to run this, so it's easier and faster. I copy paste this here. We take out version 0. Okay, so I'm running in this machine Python 396. So hello Marco, the second argument that I pass to my application, hello Marco from Python 396. Maybe I can just open here an Ubuntu shell. And run the same here. My version here is different. So here I get an hello Marco from Python 3.10.12. Following on, so I need to, I want to achieve an application package, and as it's not sufficient for me, so I want to improve my API, my command line interface API. And for this, I suggest to use a package, a Python package that is the click one. You can fetch it and you can follow it also on the GitHub page, README page. And to use it, I will need to install. So pip install. You could have a virtual environment. It's not needed for this. Pip install click. Okay. And now I can use. I think I shared the requirements also. The requirements file there. And now you will improve our code with the click package. And the click package has only two basic things that you need to comply. So the command, I think I wrote it also here. the comment, they are both decorators for our function. You can see the at here on the before, and the comment, you have a link here for the documentation. The comment will provide will make the function click command line tool. And to define the parameters, you have both the option and the argument function, the decorators. I'm using the option, and I'm saying, okay, I will have the parameter / name or n, and this will be the parameter of the function name. And this is just an help message that I want to have. By using click, it not only improves my command line interface API, but it will also provide me with an help page on my command line interface. So now if I do, we save this. If I do / help, I now have an help page for my Hello World application. And if I don't use the parameter that is required, it will say it's missing the parameter. And if I want to pass /n Marco, now I can use a command line API for accessing my Hello World example. So this is just to describe what we achieved before, and I already said this. On the other hand, I want my process, my tools to be linked with several tools. So I want to ensure that I have an output from each of the tools. And by now, what I have in my Hello World example is only a command line output from the tool. I may say here that I can create a tool that will fetch the standard output of my code. For example, I can fetch this output and serve this as a file for the next step. In the GitHub, I left an example here. That's the other file, application packaging with Hello World v0. If you follow this application package tutorial instead of the one that we are following, you can see here that, let me just highlight the important part, that I'm using I'm using the standard output, and I'm writing this standard output for that file that will be the output of the command line tool. Okay, but afterwards, if you want, you can have a check on that. Following what I was saying, now we want to ensure that the output of my application, my code, is a file. So instead of writing to the standard output, I will create a file, result.txt, and I will write my message to that file so that I can then use this file in the upcoming tools of my pipeline. So now if I run Python 3 again, it will not output to the command line. I will have a file saying hello Marco from Python 396. Okay, now I've changed my Hello World example. into a piece of code, into a script that I can start to containerize in a Docker container image. It's enoughly prepared to be available as an application package tool. So to create a container image, we do need one thing, is to ensure that we have Docker engine installed, and I forgot to start mine. Sorry. Docker desktop. Without it, I will not do anything. Okay, started. Okay, it's ran. So you will need a Docker engine available in your machine, and to create our tool, I will need a Docker file, and in this Docker file, I will need the instructions to create my image. What are these instructions? Are a set of steps that will build the layers for my container. So a container image is a set of layers or instructions, uh, or set of instructions that will provide me with a Docker image that can be run as a Docker container afterwards. So I will use these instructions here. I will just explain what I'm using here. So as a base layer, I'm using Alpine 3.12 that I think it has included the Python 3.9, I believe. This is available at Docker Hub. Show you, although I don't tend to explain with what is Docker image and the Docker containers, so I can search here for this. This is Python image with a tag Alpine 312. So this is available. It's based on this one, and you can go to tags, and then the newest one is 3.19. I'm using 1.3.12 here because of the version of the Python inside. Okay. So I'm using this one here. So this is the base layer. And then I'm saying, well, my work directory where I will put my files is in /opt of the machine. I'm copying both these files, the requirements that I didn't copy here. Let me fetch the requirements. But it's easier. I will create one quickly. I'm copying this file to that file on the machine. I'm copying also the requirements file to /opt, and then I'm installing my requirements. And as I said before, use CMD. And if I don't pass any comment to my container image, what it will do is to output an help message on how to use the code inside. So let me just edit this. I want to use Hello World. This one. I don't have a requirements file. Let me create one. With only the click. Okay. With my Docker file created, all I need to do is to run the build command. Okay, and the build command, what I'm saying is, okay, build me an image on this context using the Docker file and tagging my image as hello world version 0.2.0 and avoid using cached layers. Sorry. Okay. Solved. Now, what happens is that I do have a new image on my Docker engine that is created with this tag and with this code as inside already an hello world py script, and will produce the results that I expect to have available. To test this, well, I can run my container image. And by doing run, I'm saying which image I want to create a container with and execute it. And as I'm not passing any parameters to my container, it will run the command line interface that is defined, the command that is defined in this instruction. So what it says, okay, you need to use hello world py with the options, and the options available are either help or minus name and the name that you want to greet. To run and see the results, we will have to use a little bit more complex command. I'm building, I'm mounting a volume that will create a folder here that is the result, that will fetch the outputs of a folder within the container. And I will do, okay, I want to run Python hello world -n Marco, and I will want to copy the file that I'm generating into my volume. We will not need this anymore, so I will just run this command. Oops. It should have worked. World tutorial. Let me try here. I think I'm having an issue on my CMD interface. Okay. So here is hello Marco from Python 395, not the one that I'm running here, 3.10.12. Why? Because I'm running my Python script within the container image. So my application package too. What am I missing now is to allow to tag and make sure that you all can use this container image. In fact, I've created, I forgot to open here. I've created a repository for these tools that you can see here. That you can see here, and you can see that some time ago I already generated some versions. I'm actually on version 0.020, and I will update this image now. So to update an image, and what we will need to do is to change the tag. So currently my tag is hello world 020, and I want to make it on this repository, and this repository is Amaro Oliveira / hello world. So I will need to do this rename of the tagging from hello world 020 to my repository. That's this name 020. That's the tag name. Okay, it already changed. And now I'm pushing this version that I have into Docker Hub. So now, if you just type Docker run with Amaro Oliveira hello world 020 on your machine, you can fetch this image here, and it will run on your computer. So what am I missing now? I'm missing the description. And to describe the application package tool, I will need the CWL file. So, and I will jump into the CWL file. And now I want to describe my tool. To describe my tool, I will generate a new file, a new CWL file. For sake of easiness, I like to include the versioning on the name of the file. So this will be the description of the Hello World tool in version 020. And to describe, I will copy, paste, and explain on the editor. And to describe the application package, I will need the version. This is mandatory for the CWL file, the CWL version. I will use the namespaces from schema.org, so I will need my prefix S for schema.org. So every time you see S, 2 points, sorry, I forgot the name of in English of this element. Every time you see this tag, you are using elements from schema.org, and you will have an acyclic graph describing a class of type command line that says my main execution instruction is Python. The ID of this command line is hello tool, and the arguments might be better to understand if I do it like this. The arguments for my base command is I will call hello world py with the parameter name, and the value that goes afterwards the name comes from inputs.name. And inputs.name defines me which are the inputs that I have for my application package. In this case, I'm saying my inputs are only one, name, of type string, and the description is the name of to greet. This application package tool will output an element called result that comes from the file. It's a file, and the name of the file is result.txt. This is the documentation for that output, and the file format is text plain to understand. The requirements for this tool, we do need to have the inline JavaScript requirement. This is a CWL requirement, and we will need the Docker requirement to pull the container image that I just uploaded into Docker Hub. Furthermore, we do have some mandatory and optional metadata from schema.org that we had. namely the version, name of the tool, the description of the tool, some keywords, programming language, source organization, author, contributor, code repository, and the date created for this tool. Once you have the CWL, you can provide the CWL in somewhere that is available on the web. I shared this CWL on GitHub, and then with this CWL, you can share it as an application package, in this case, as a command line tool in the registry. I just made it, I did it before, so all that metadata is interpreted and placed in described here. This is a link to the location where the CWL file is, and we can also provide machine readable and machine interpretable versions of the tool. But this is the tool, and we also need to have the pipeline. So this tool can be used. I can use this tool directly from the command line. It's similar to the pipeline, but I will describe the pipeline now. So to describe one tool, we do use a class of type command line tool. To describe a pipeline, we use the class workflow. And within the pipeline, we do need two things. We do need at least one only workflow, and at least one command line tool. So this is a copy exactly from my tool. And this is the part that we add to the pipeline. We describe it as being of type workflow. The ID and the documentation is mandatory. We define the inputs for the workflow, and we describe which steps will be performed in this workflow. We only have one step here, that is the hello. This is just an identifier of the step. You can use anything, and it will run my hello tool. So this links to this identifier here. The inputs will be name that will come out of the name input. So this is the input for the tool, and this is where this value will come from, and it will result in an output as with the name result. The pipeline will provide these results that comes from the hello step as output of type text plain. And we do also need to have the documentation for the pipeline. That may be different, of course, from the documentation from the command line tool. So I will copy this into my description of the application package pipeline. And once I have it described, I can use it to run my application package. So I can share also on the registry. We've seen this with the tool, but it's equal to the pipeline. And to run this tool that is available, I can just, for example, I connected to a machine that I have on the cloud, where I'm preparing to install some software. I already have in this machine the Docker engine installed. I installed CWL tool, that is a tool to read and to process and orchestrate the processes within a CWL document. using apt get install CWL tool, and I will just tell it, please run my pipeline that is available on GitHub. I want to run my workflow hello pipeline, and I'm passing the parameter name Marco. And as I'm running this, it will fetch the CWL file. It will run the CWL, it will download the container from the tool. It will run, and it says, okay, you should have in home Ubuntu result txt the file that was generated from your container image from the tool I just shared. The same way, and I know it's already 12 o'clock, but I will take 10 more minutes if you don't mind. The same way, so this is for an Hello World use case, but the same way you have another tutorial there. Let me copy this to the Discord. And in this case, it's a little bit different because we are sharing there a Jupyter notebook. I also added here a collab file. Forgive me if there are any mistakes here, but it was done during last night. So my idea here was to have something that would resemble a data processing tool that you are working on, and I just remember that we have some data sets from some campaigns that we did during the La Palma campaign, volcano eruption, and these data sets were made available publicly available on NextGeos, so you can search for them. They are available here. You can download them from this link. This is also available in the catalog of the MLOA project where this was created. You can the link is the same. You can also fetch it from here. And so what I thought was to implement something that from that data set that has 4.5 thousand observations. What I thought is to, okay, but I want to extract only a part of the data set. I want to see which of the values on data set have temperature. So I'm searching for the temperature values on the temperature that are above or equal, greater than or equal to 24. So I'm having here three constants on the collab file notebook. And these constants allow me to define which is the operation I want, which is the value that I want to search for, and the link for the data set. So I will import my required packages. It's taking a little bit too long. Probably it went shut down. Okay, it's already running. Okay, I will define the constants. I do have here a method or a function to extract my bounding box from the selected point observations that I will use. And then what I will do is fetch my data set, define here an output dir for my results. define which are my comparison operations that I have available, ensure that the comparison operation is available, and then go through my initial data set and search. So compare use the operation and the values to identify which of these values will be on my final data set. So this should have made here. Here, this is my result data set. I'm also fetching some metadata that I will need to for the next tool. So I already created here a set of metadata with the description, with the geometry of the values. This is a GeoJSON value with the media type and the start date time and then date time, so that I have a time bounding box also well defined to create my stack file in the end, and the bounding box of all the data that is achieved. This is written to those two files. We can see it. Let me. So this is the metadata. This is the final CSV file here. And I wanted to display this in some sort of a manner. So I display in a map format where I have in red the description of all the points that I have in my original data set. And I'm showcasing, I'm highlighting only the values that the observation whose values are greater than or equal to 24 degrees. Let me just do another change here and let me put lesser than, I already prepared this, lesser than 22, and run this again, run everything. Okay. So if I go to lesser than 22, you can see that there the water temperature was at 24, and here by the end of the data set you have lower water temperature. Okay, what to do with this? I want to have this as a tool in my application packaging, in my application package pipeline. I know that it is defined that the output of a pipeline should be a stack file, a spatial temporal asset catalog file. And I also know that we have here keywords probably to stack. We do have one stacks only. It's only stack, sorry. Okay, we do have one tool, one command line tool that is already prepared, and that will accept one file and any format, and it will accept another file that will be the metadata file. So the same two files that I already created in here. So what I will do is to transform this notebook into a tool that I can use in a pipeline and that I can reuse anywhere in any of my environments. So this is what we are doing here. So first thing that I will need to do is to create my Python file. Close everything here. And wavy ocean.py. Okay. And I will extract, I will copy this to be faster, but this is mostly what I have on the notebook. I extracted the constants and used the click package to define three parameters for my command line interface API. So I have the operation, I have the base value, and I have the address of the data set. Then the rest is mostly the same. Just take into consideration you need Python 3.10 to run this because I have this case operator, and this was only available on Python 3.10. And the rest is mostly the same. No more changes. It's writing the metadata file. It's also writing the final CSV file. Of course, you don't have the map here because what we want to obtain is the CSV file from this tool. And you can test it. You can run if you want. So we'll need to run it on the WSL interface that I have the Python 3.10. So it run. I do have the result here. I have my CSV file and my metadata file. My tool, my Python script is working. You already have the help file. Of course, you've seen this in the other example. And now we are going to package this into a container. I will create my Docker file. And I will use a different version of Python. I will use the tag Alpine 319 that uses already the Python 3.10. I'm working on my OPT option folder from my virtual machine. I'm installing Clip, not using the requirements file, just to be different from the previous one. Copying my Python script into my image and defining my command, the default command that I want to use. I want to use if I don't pass any command to my container. So this is just what we did before also with the Hello World example. Having this, we can now create or build our image. Docker build this folder tagging Mloa Wavy Ocean filter with version 0.10, avoiding cache on the layers, cached layers in this case, but he is already using one. Okay, and we can run just to test that we get the help. We get the help. I can either use this here or in this one on the other environment. So in one is Linux, in the other is Windows. Wait. Just to show you. Yeah. I could run and fetch the results. Wait 1 minute only. And the results are here, the metadata and the results CSV for that file. And now we could tag it to my container repository on Docker Hub. I will jump this one because I prefer to go directly to, because it's already there. In fact, I will describe my command line tool, or I could already jump directly for my pipeline. That's more relevant in this case. and you can go through this tutorial afterwards. And by describing the pipeline, now I'm using not only my tool, but I'm also using the tool to stack that we shared on the registry. So what I will need to have here, and let me go to the registry. So my to-stack is available, the CWL file is available on GitHub, and you can see that I use this description here for this tool, and this is all defined also. Let me find it like this. It's all defined here. So here I'm defining the same description that I have on my to-stack tool. Okay. Here I'm having the same description of the tool from Lower Filter. So my Lower Filter tool will run the Python Wavy Ocean, passing the URL that comes from inputs URL, passing the base that comes from the base value, and passing also the option that the user inputs if it inputs, because it's not mandatory. The inputs for the tool are URL, base, and option with the type string, float, and string not mandatory, using the default greater than. It will output not only one file, but two files, the results and the metadata, both a CSV and a JSON file. So my pipeline, whose ID is filter, has as inputs the same inputs that we have on the tool, and it's based on two steps. The first step is to run the filter, and the second step is to run the transformation of the outputs into a stack file and a stack catalog file. And it will use as inputs for the second step the results from the first step. This output will be the output from the overall pipeline. It will be a directory with a set of files in it, and it will result from the results from the second step. And the metadata is already defined. I already went through it, so I will not go over it again. So to run this, I do have this already registered in the registry. I do have this available on the on GitHub, the CWL. And so if I have access to the CWL, this is at this address, I can just, without having anything about this in my cloud machine, I can just request to run that pipeline, the CWL, the tool filter, passing as base the value 24, using this data set. And as I'm not passing the operation, it will use greater than, because it's the one that I defined as base value in case of not being passed to the execution. So running this, it will read and interpret the CWL file. It will fetch the containers both from the tool that I created and the tool that is available in the registry. And from this, it outputted my directory. And so I can just go into the output directory and do fetch my stack catalog file that says it has two items. So I need to go into result and see my result JSON. That is the second catalog. Where is it? Here. And you can see that it has a feature. The idea is result. It has a start time and a end time, so a bounding temporal reference for the results, only the results. The definition of the observation that have that value, so greater than 24, and it provides me the description of the assets that and the bounding box of the results, of course, not the original data set, but only for the results. And now I can go into CSV. And this is the output of the application package. So sorry for taking 20 minutes more than I expected. We started at least 10 minutes later, so only 10 minutes more. This is what I wanted to show you. In the presentation, I have some more slides just for reference of some things that you can do. I didn't talk about the API for the process. So now that we have the application packages, we could use the processes API to deploy these application packages in cloud machines. This would deploy into a Kubernetes server, and we can then run a request execution and even undeploy these processes from there. And that's all. Thank you. I don't know if there are any questions that you want to have, or afterwards, if you want, I am available to answer them.
Thank you, Marco.